All right, so looking at the first problem that we have, we want to use the graph to find each of the following. This dotted line that you have in your paper is not really there. My graphing program just likes to put it there for some reason. So if I'm looking at this equation, it says to first we want to find f of 0. So what is f of 0 equal to? 8, because we're looking for when we have an x value of 0, what's our y value right up here, which is 8. So f of 3, what would that be equal to? A y value of 1. So when we have x value of 3, we have a y value right here of 1. Then the domain of my equation, can anyone give me that?
Negative infinity, 1, union 1, 1, 7, parentheses.
Is that what everyone else got? So notice that our values are keep going down, so we're going all the way up to 1, then we have an open circle here and an open circle there where no x values are accounted for, so that's why we have the parentheses around the 1, and then from 1 we're going all the way to 7, not including 7 because of that open circle, therefore this is my domain. So then, does anyone want to give me the range for this?
Parentheses, negative infinity, comma, 8.
Good, because our graph is going all the way down from infinity. Here we have an open circle, but that y value is taken care of there. This y value is taken care of here, and this one's taken care of right there. So we're going all the way up to 8 and stopping. So that would be our domain. And we've talked about that before, so hopefully you guys are getting good at this. Does anyone have questions over A, B, C, and D?
I just have to. I always mess this up, but if there's like a hole, and but across from it there's a line but not like a dot, it still fills the void.
Right, right. If there had been another hole right here instead, then we would have to have an open circle and we wouldn't include that point. But since this y value is taking care of this hole right here, then we're okay. So then if we're looking at the next one, example 1, it says find the domain and range of the function. So again, these should be fairly easy. So if we look at number 1 together, I know my domain, if you look at your x values, we have x values coming from negative infinity all the way to negative 1. There's nothing in between here, and then it starts back at 1 going all the way to infinity. So I know my domain is going to be negative infinity, comma, 1, bracket, union, bracket, 1 to infinity, because there's no open circle there.
Negative 1.
Oh, yeah, you're right, negative 1, thank you. Negative 1. Because we have a gap in between those points. So who can give me the range for this one? Where are my y values starting at? 0. So now my y values, remember, go this way. So y values start here at 0, and they're going to where? All the way to infinity, because the arrow's on the end of my graph. So we have bracket 0 to infinity, parentheses. So then for the next one, my domain, this is a parabola. Obviously, it's an upside-down parabola, so it's just an x squared. Can anyone give me my domain here? Right, negative infinity to infinity. Now, the range, however, is not all real numbers. The range, what is the highest point of my graph that I'm starting at? 2, and I have numbers below that, so my range is different. My range would be negative infinity to 2, bracket. So not always just because we can plug everything in for x can we get everything out for our range values. And this is the case when you're working with radicals, absolute values, and also quadratic equations. You have to watch out. For my domain here, for this last one, this is absolute value, and of course we moved our graph to the left 4. So what's the domain of this Right, again, negative infinity to infinity. What's the range of my graph? Right, starting here at 0, going to infinity. So bracket 0, comma, infinity. So you guys need to get good at that by looking at your graphs, telling what your domain and range is. And we've already talked about some of that before. So then the next part of what I want to talk about just real quickly is we have the vertical line test. So the vertical line test, remember, just tells whether or not we have a function, so we're not going to spend very much time on this. Looking at A, is this a function? No, this would not be a function. It does not pass the vertical line test. What about B? Not a function. Again, does not pass the vertical line test. What about C? Yes, it would be. Because even though we have overlapping parts, there's an open circle here and a closed circle there, therefore it does pass the vertical line test. And what about D? Does this pass the vertical line test? Yes. Okay, so I'm going to go back. So the new thing that we're going to talk about today is intervals where we're increasing, decreasing, and constant. So when you're talking about something increasing or decreasing, you always look at your graph as you move from left to right. And that makes sense because we want to go from our negative values to our positive values. That's how you're going to kind of determine whether or not your graph is increasing, decreasing. What are you looking for? You're looking for, as you move from left to right in the graph, what are your y values doing? Are your y values decreasing or your y values increasing? Or are they constant, which means are they on a horizontal line? When we are doing these, you have to state whether or not you're increasing, decreasing, or constant because we're using interval notation. And since we're using interval notation for this, we're going to use our x values. And if you don't say whether or not you're increasing, decreasing, or constant, then somebody might get confused that you're writing down the domain, or they might get confused that you're writing down the range. We don't really know what you're talking about unless you define what it is you're talking about. So if I look at this first graph that I have right here, as I move from left to right on my graph, as I go from here to here, what are my y values doing until I get here? Decreasing. And then as I keep going, what are my y values doing? Increasing. So that means, what would I have to find in order to tell where the change off is? I need to find what the minimum point on my graph is. So maximum and minimum points are very important to find in order to tell where your graphs are increasing or decreasing. So we'll practice that. So just for right now, we're going to guesstimate where it looks like it is. So it looks like it's at 5, 6, negative 7 for the x value. So I know that my graph is decreasing from, so it's decreasing on the interval from negative infinity to the x value of, in this case, negative 7. And we use parentheses around this because that point is where it's changing. So we don't say that 7 is increasing or decreasing. It's neither doing either of the two things since it's the point that we're changing over. So we use parentheses. And then from negative 7 on, we said we were increasing. So parentheses negative 7 to infinity is how I would write that. And again, the key to remember is that you're using your x values. So make a, I would highlight this part right here, using x values, because eventually we're going to do some other things and it might get a little bit confusing when we add stuff. So if I look at the next graph right here, as I'm moving left to right on my graph, is there a point where my increasing and decreasing is changing, or what's my graph doing the entire time? As I'm moving, what are my y values doing as x is increasing? They're increasing. Is there any place where it looks like it's starting to decrease? No. And it's a little bit hard to tell right here, but this graph just, it is slowly increasing. So this one doesn't have any decreasing, so there's not really any max or min points. It's just a cubic equation. So for this, I would say that this is just increasing on the interval from what to what? negative infinity to infinity. So as my x values are increasing, my y values are increasing over this interval. And if I look at the last one, this is a horizontal line, so this would be considered to be constant. Now constant's different, so if it didn't have the arrows on the end, we know we're constant from negative infinity to infinity. If it didn't have the arrows, and let's say it had like stopped here at -5 and 5, then since I can be equal to -5 and 5, since it's constant from those two numbers, you would actually use brackets, so constant's a little bit different. However, in this case, since we have those arrows on the ends of our graph, it actually is constant from negative infinity to infinity, and of course we don't use brackets around infinity. However, if it was from -5 to 5, I would do bracket, -5 to 5 bracket, and then would say it was constant. Questions on those three?
So for the other two, we don't use brackets.
No, you always use parentheses because that point, which is your maximum or minimum point, that's where it's either changing from increasing or decreasing, and so since we don't know which one it's doing, we can't say that we're including the point for the increasing or decreasing. So why don't you guys do this example right here. So looking at this graph, as I'm moving from left to right in my graph, what's the first thing that's happening until I get to about right here? We're decreasing. So we're decreasing from negative infinity to where? 0, because remember you're using your x values. So decreasing from negative infinity to 0. Do I use a parenthesis or a bracket? Parenthesis. And again, a lot of students accidentally write their y values down. Do not do that. It's the x values. So then what are we doing from here to here? We are constant. So we're constant from bracket 0 to 2 bracket. And then from 2, as we're moving along, our y values are increasing. So from 2, parentheses 2, to infinity, we are increasing. And again, yes, you need to write increasing, decreasing, or constant. Otherwise, you would have no idea what you're talking about. Questions? Okay, so then before I have you guys do some of these problems on your own, I want to talk about maximum or minimum points. So local maxima and minimum. So we know that the peaks and valleys of your graph are what we call our maximum and minimum points. So the turning points for where the graph shifts from increasing to decreasing. So these are very important points to find when you want to find your intervals for increasing, decreasing, and constant, because that's where we're going to stop. So here and here, I know that these 2 points are the what of the graph? Maximum. And then maxima and minima are just what we say, the plural is, it's just plural for maximum and minimum points. So are these the actual highest points on my graph? No, because my graph's going to infinity. So we don't actually call these, there's 2 words, absolute maximum and relative minimum, or sometimes people use local minimum, so, or local maximum or minimum. So in this case, we would call these relative maximum points. And these other points that we have right here and here, these would be called the relative minimum points, because relative to the points around them, they're the lowest. However, because our graph is going to negative infinity right here, they are not the actual lowest points on our graph. if instead I had maybe something like a parabola, so let's say I had a parabola maybe looks like this. Now this isn't the relative minimum, this would be the absolute minimum because it is the absolute lowest point on my graph. So what I want to do is we're going to do this first problem together. So get out your calculator so that we can look at it. And we are going to find the local max and min, the intervals where we're increasing, decreasing, and we're going to talk about finding the x and y intercepts. Load up. All right, so looking at this in your calculator, you're going to put negative x cubed plus x in your y equals, and then hit graph. So if your stat plot's on, you might get an error, so make sure you turn your stat plot off if you had it on from previous. The equation is, it's on your paper, so negative x cubed plus x. It might be on the other side. So hit zoom 6 because we want to just look at a standard window usually first. If I'm looking at this equation, I want to find all the intervals, the x-intercepts, and everything on my graph. So in order to do that, this kind of is hard to tell what's going on right in this little middle part here. So what could I do to figure out what's going on inside here? Zoom in. So if I zoom number 2, which is zoom in, I'm going to zoom in and hit enter right there with my cursor there so that it's zooming in on that middle part. And that gives me a better idea of what is going on inside my graph. So the first thing, if it asks you to find the intervals where you're increasing, decreasing, and constant, the first thing you probably want to find is what? The maximum point or the minimum point, because that's the places where they turn over from increasing to decreasing. So those are the first things I'm going to find. So how do we find this point right here, which is a minimum, and this point right here, which is a maximum? We have to use our calculator. So second trace, and of course we're doing number, let's do number 3 first, which is the minimum. So scroll over to where you think the minimum point looks to be about, which is somewhere around here. So then it says left bound, so you want to go to the left of that point somewhere. Doesn't matter how far left you go, just close enough, and hit enter. Go back to where you think your minimum is, so I hit, and then you want to go to the right of that and hit enter. Notice that you have these 2 arrows right up here. You always want the minimum to be in between those 2 arrows because that's where it's going to guess. So now if you hit enter on guess, your calculator nicely figures out where the minimum is. So that's the first thing I'm going to write down. So we have, and this is this an absolute minimum or relative minimum? It's a relative minimum. So we have a relative minimum at, it's hard to read this screen, so negative 5.5773. And since this is a point, would I want to write the y coordinate? Yes, because it's a minimum point. So you guys should also be writing this down on your paper so that you have it. So the y value is negative 0.3849. That's a point right there. So that's the first thing I want to find. So while I'm doing the maximum, you guys are also doing the maximum on your calculator. So when you do that, you should end up with a relative maximum of, so relative maximum point, and again, it's a point, so we want to write the whole thing. So in this case, we have 0.5774, comma, 0.3849. So that's my relative maximum point. So now that I have that, I can easily figure out the intervals where my graph is increasing, decreasing, or do I have any constant on this graph? No. So for this graph, I know that as my graph is moving from left to right, when I get to this relative minimum point right here, what is my graph doing right here? It's decreasing because as x is increasing, my y values are decreasing. So I know from here to here we are decreasing. So then I'm going to write we are decreasing. And what's the interval that we're decreasing from? Parentheses, negative infinity to the x value of my minimum, which is negative 0.5773. So that's where I'm decreasing. And then from my point here to my point here, which is my relative maximum, what are my values doing? So as I'm moving from left to right, I know my y values are increasing. So then the next part we're going to say is that we're increasing from this x value, which we said was negative 0.5773, comma, to this x value, which is our relative maximum x value, 0.5774, parenthesis. And then for the last part from our maximum going this way on my graph, what's happening? We are decreasing. So then we are decreasing on the interval from my x value, which is of my maximum, which is 0.5774 to infinity. And notice that every point's accounted for, so you shouldn't have any gaps unless we're doing piecewise defined functions. So I have a continuous graph right here, so all my x values should be taken care of, which they are when we go through this. So questions on how I found that. You need to find your maximum minimum points.
Why can't you just combine like your decreasing?
You can put the decreasing together if you want. I just did it in this order to show you that all of my x values are taken care of. So that way I don't miss something. But if you want to just write decreasing and write all together, that's okay. So then the next thing we want to find are the x-intercepts. So the x-intercepts are easy to find with our graphic calculator because what can I use? Right, so if I go to second trace and we have our zeros is what we're doing, so number 2. So in order to find the zeros, I'm going to do the first point, that's all the way over. How many zeros do I have on my graph here? 3. So how many times would I have to do this? 3. So I'm going to erase this right here so you guys can see. So we have an intercept here, here, and here. So remember, when you're finding something to the left of where you think the 0 is, your graph is on this part of here. So this would be left bound, this is right bound, and then enter to guess. So left bound is above the x-axis, enter. Right bound is below the x-axis, enter. Oops. So left bound, enter. Right bound, enter, and then enter on guess. Notice that my 2 arrows are in between where my point is for my intercept. So that's what it should always look like. So then enter. So I get an x-intercept of x is equal to, in this case, -1. I don't need my y value here. Then I would do this point right here, which is easy to see without even calculating it. What's it going to be? 0. And then if I do this value over here, left bound, right bound, I would get 1. And then the other thing we need to do is find the y-intercept, which is easy to see on this graph because it's 0. But if you couldn't see it, something that's easy to do is hit second trace if you do number 1, which is the value. As long as you can, as long as you can see the y-intercept on your calculator, you can do this. If it was way above my graph and it wasn't showing in my window, then it would say error if I plug it in. All you have to do is hit 0 and enter, and notice you get your intercept is 0. So I would say my y-intercept is just y equals 0. So that's what your homework's to be like, those intervals where you're increasing, decreasing. So again, it's important that you have to find the maximum and the minimum points on your calculator. And then your x-intercept's easy to find with your calculator, so it's your y-intercept. If you missed a lot of your homework from last night, you might want to come in for lunch to look over it, since I'll be checking it at some point.
Are we gonna like finish this class?
Yes. I'm going to actually plug. I didn't check anyone, so I'm going to probably look at it tomorrow. Just because we didn't have enough time today. I always seem to run out of time. Got too much I want to teach y'all. Too much learning. I like your paint. They're pretty colorful.